Here for problem number 4 of chapter 1, we're looking at points that are generated in a unit square. So they have an xy coordinate within 0 and 1. And we're looking at 2 points to see the distance between the two. And for the first part of this problem, we are looking for the mean and the variance of these randomly generated numbers. And we can see that we're generating an x and y coordinate for every single one, and then seeing the distance between the two, simple triangulation, and then we'll look at how many are greater than 1.4, which will come later on, and then the mean and the variance. And running this section of code, we can see the distribution with the mean around 0.5, and way down there is 1.4, where it appears to be extremely unlikely, and we can see even from the 1 million samples that we generated, there were none that were greater than 1.4, while the mean was 0.5 and the variance of 0.06. Now, we saw that empirical distribution as well as the estimation and the variance. And now we're going to look at a method to determine what the probability of the distance being greater than 1.4. And just to get a visual image of what this looks like, here is a circle with a radius of 1.4 and our unit square right here. And we can see that there's a very small area where we can have a number generated, even just to be eligible to have another number generated in the opposite corner that's exactly 1.4 distance away. So what I have done is set up our own 4 separate squares where we'll be generating numbers into, and it will be assuming that we get into the opposite square for the second number being generated, and using that distribution to determine what the probability of getting greater than 1.4. So in this case, using some triangulation, we discovered that at the origin, in order to have another point that is 1.4 away, we need to develop a square, or in this case, a triangle, a near triangle, since it's a circle, and a very small length. And this square length, we decided to do the distribution in, has a distance of 2/100ths. And we'll be generating random numbers into there, and in this case we'll be doing 10 million, generating the random numbers, and then by multiplying the probability of finding one within one square and then one within an opposite square, which is the same probability divided by 4, we'll then multiply this probability overall by the percentage chance that our own distribution falls within the 1.4 distance or greater. So running this section, we can see that the answer we come out with for the first run is 2.7 times 10 to the negative 8th, and that gives us a pretty good estimate, as when we run it again, the variance is very low. We can see that our second estimation is very, very similar. Thank you for watching.